Hello, growers. Say goodbye to heavy sandbags and hello to modern growers' quick hoops low tunnels. Protect your plants from pests, wind, rain, and frost without the hassle of sandbags or flimsy hoops. Our patented design eliminates the need for clamps and ropes, while the unique wire system keeps covers secure yet easily accessible. Tested in the strong winds of New Zealand for over 20 years, quick hoops are light, strong, portable, and versatile. Most importantly, they're designed for field use. These aren't some lightweight system that only looks great in a greenhouse. Our hoops are designed to last in harsh field conditions. Use them with any covering to grow year-round and safeguard your crops. Shade cloth, frost blanket, insect net, clear poly, no problem. Quick Hoops can handle them. Get Quick Hoops today at shop.moderngrower.co and protect your crops for years to come.
Is this correct or is this not correct? If I have a basil plant and I'm looking for something resistant to downy mildew, in theory, I go out and I plant 1 million seeds that somewhere within those 1 million plants that grow up, one of them is going to be resistant, and it's up to me to find that one. Is it this idea that if there's enough plants planted, if there's enough population, that there's something, one individual plant within that population that probably has the traits that you want? Or does it require more encouragement through, okay, here's one that's resistant, now we need to try and amplify that somehow?
Theoretically, that is possible, that given enough plants, because every time a seed gets produced, there are errors made in the replication of the DNA that creates that seed. So theoretically, it would probably take much more than one. For example, if you're looking for disease resistance to downy mildew or powdery mildew, theoretically, if you planted billions and billions of seeds, yeah, one of them probably would be resistant, just because you get mistakes in DNA replication. But we don't use that strategy so much, that kind of big mass selection strategy so much, because it's just not feasible really to plant that many plants and screen them all. So along the lines of what you were just describing, one strategy you could do to not to have such a large population of plants is you could subject the seed to either radiation or a chemical treatment that would actually cause mutations in the DNA. And so for every plant, theoretically, for every seed, then you'd get a random mutation in the genome. And then by probability, one of the mutations would cause a resistance response in one of the seeds. So that's an old strategy that's actually been used for a really long time. But it's not the most common. If you take a trait like disease resistance, I would say one of the most common methods, if not the most, is actually to go out and look for a really wide diversity of different, in our case, different basil plants. If you, for example, a tool that a lot of breeders use, especially in traditional breeding, or a resource, is the USDA germplasm. USDA offers a lot of resources for a lot of different crops in the form of land races or plant seeds that have been collected from all over the world. So if you go on there for basil right now, there's a few hundred different basils freely available that have been collected from Africa, from Asia, from South America. And often what you'll find when you're especially looking for disease resistance is you'll find your sources of disease resistance in wilder versions of the domesticated commercialized crop. And that's what we did to produce the disease-resistant varieties that we have. We went out and looked at the entire USDA germplasm, and we went and looked from other seed catalogs for heirloom seed, and we eventually found a lot of plants that had disease resistance.
Well, in theory, all of these plants at one point in time, they're wild. They evolved however they evolved, and they're out there. Somebody notices it and says, oh, this is food. I can do this. But it doesn't taste so good. Have we just over maybe thousands of years bred out a lot of disease prevention characteristics in favor of flavor, size, appearance, those types of things? Is that why the wilder plants tend to be more hardy?
Yeah, I think what's happened in a lot of crops is you get what's called genetic bottlenecks where, and this probably happened more in the last century than over the thousands of years when there was selection going on, but it was as simple as someone would see a plant that was growing very vigorously or yielding very high, and they'd say, oh, that looks like a good one. Let me collect seed from that and I'll go the next generation. But of course, 5,000, 6,000, 7,000 years ago, no one understood how traits were inherited. But what you do find, going back to your question, is definitely what you're alluding to, which is in a lot of crops, and basil is not an exception, the commercialized versions that you find in the seed catalogs represent a really narrow section of the genetics available for that crop. And that's a result of, maybe you could argue, some poor breeding or some just lack of awareness in breeding, probably early on, where certain traits were selected for without an awareness for maintaining diversity of genetics in the overall germplasm that's used for a given crop in the available resources. And so we found that in basil, and that's been found in a lot of other crops, that what's out there in the commercial market, in the commercial seed catalogs, represents a really narrow base of genetics. So what's been happening more recently is, for quite a while, is people have been going back to these wild resources and crossing them in to the commercial resources in order to broaden the genetic pool and recover things like disease resistance. But when it comes to, I think you mentioned flavor, flavor is actually a trait that's been really left by the wayside with commercial breeding. And probably the best example of that is in tomato, where until recently, the only thing that was bred for really was things like shelf life and actually disease resistance and yield. But flavor was actually left back with the heirloom varieties, which don't have any of those traits. And so it's only recently actually that people are starting to go back to the wild plants in search of flavor, because it was left out of the main gene pool that, again, you find in the commercial seed catalogs.
If you enjoy this podcast, then be sure to check out Farm Small, Farm Smart Daily, where you can get your daily dose of farm wisdom. Tune in every day to learn the latest tips, tricks, and stories from the world of farming. Whether you're a seasoned farmer or just getting started, our podcast has something for everyone. Join us as we explore topics like farm business, crop planning, soil management, and tools and technology. Start your day off right with Farm Small, Farm Smart Daily, available on all major podcast platforms. Don't miss out. Subscribe today.